On a piece of paper, I want you to draw any size triangle you want. I would not draw a small triangle. And where the three angles are, I want you to draw arcs. And when you're finished drawing your triangle and you have your arcs drawn in, please restart the video. Okay, the next step after we have our triangle drawn is to measure the angles. So I'm going to use my protractor. It doesn't matter which angle I start with, but I'm going to start over here on this side. And before I measure it, I just want to look at it and ask myself, what kind of an angle is that? Is that an acute angle, which would be less than 90 degrees, a right angle, which would be exactly 90 degrees, or is it an obtuse angle, which is greater than 90 degrees? Well, when I look at this angle, I can see that it is an acute angle. A 90-degree angle would have been an angle that would have gone straight up and would have formed a right angle. In other words, there would be a corner there. And this one definitely is less than that. So I'm going to put, on most protractors, there's a hole that I can actually stick my pencil through. If yours doesn't have a hole on it, there is probably a place where the two lines intersect and meet, and it might look like a plus sign there. But if yours does have a hole, stick your pencil through it and then put your pencil on the vertex or the very point of your angle. The next thing you want to do is you want to get this line right here lined up on top of the line that you drew. So that looks pretty close to having this black line on my protractor lined up right on top of this line of my triangle. Following this line out, I can see that I run into two numbers. I run into 0 and 180. I actually run into the 180 first. When I'm measuring on a protractor, I want to use the set of numbers that starts with 0 when I follow this line out. So I'm going to use the set of numbers that is on the outside of this protractor to read the number of degrees that this angle is. And I know it should be less than 90, so it doesn't make sense to use the inside numbers. It makes more sense to use the outside numbers. So when I look at my angle here, it looks to me like it's about 23 degrees. So I'm going to write in 23 degrees here, and then I'm going to go to another angle. I'm going to come over here to my angle on the left, and I'm going to put my pencil through that hole and put my pencil on my vertex and line up this black line on top of the line that I drew to the best of my ability. And again, I'm going to follow that line that's underneath my black line until I come to the 0, and I'm going to then follow that up until I get to the point where my line is crossing through my protractor. I know I'm going to be looking at the smaller numbers because I'm following my 0, my line of numbers that begins with 0, and I can see that my line is crossing between 40 and 50. And when I look at it, it's less than 45, so I'm going to say this one is 44. I may not be exact, but I'm pretty darn close. To measure this angle, I'm just going to rotate my paper around. I could use this line to set my protractor on, or I can choose this line to set my protractor on. It doesn't really matter. I'm going to choose this line down here, and I'm going to set my protractor on it, put my pencil through my hole, line up this black line so it's on the line that I drew for my triangle. And I notice that when I follow that black line that is over the line of my triangle, I come to 0 first. So I'm going to follow the set of numbers that are on the inside of my protractor until I come over and see where my line for this angle intersects that set of lines that are on the inside of my protractor. And again, I can see it's going between 110 and 120. So when I look at it, I have to make an estimation there, and so I'm going to say it's 114. So I'm going to write 114 for this angle. So now I have my 3 angles of my triangle measured, and I can see that this one is less than 90 degrees. That makes sense to me. This angle measure, if it was going to be 90 degrees, my line would have had to have come up this direction. So that makes sense. It's less than 90 degrees. This one, if it would have been a 90-degree angle, it would have been approximately right here. That would form a 90-degree angle. So this is an obtuse angle. It's greater than 90 degrees. And I can see that when I measured it, I did get a measure that was greater than 90 degrees. The next step is to cut out this triangle. So you might want to stop the video now and cut out your triangle, and then start it again when you have your triangle cut out. So here's my triangle cut out. The next thing I want to do is I want to tear. Don't use scissors. I want there to be a rough edge. We're going to tear off all of the angles of our triangle. We're going to rip them. So I'm going to have 1, 2, 3 angles torn off. And this is what I have left of my triangle. I can just throw that away. I can just discard that. What I'm going to do with these 3 is I am going to arrange them so that the straight edges that were once part of my triangle are up against another straight edge of a triangle, so that the vertexes or the points of the triangle are all pointing the same direction. So in other words, I would line this one up like this, and so my rough edges are all going to be on one side, and my straight nice edges are all going to be on one side. And so I'm going to align them up so that they look something like that. Now, where I put each one doesn't matter. It doesn't matter if I have that 23-degree one in the middle, if I have it on either side, it should not make any difference. And what I'm going to do is I'm going to tape or glue these down in my notebook. So once you get them torn, if you want to stop the video and you want to go get some tape or some glue, that would be a great thing. here is my notebook. So I'm going to use tape. It's easier for me. So I'm going to tape down one of them. And remember, I want to have my rough edges on the outer edge, and I want to have my straight edges lined up, touching each other. So that when I get done, and I have all of the vertexes of my triangles converging at one point, I notice that they form a straight line. I can draw a straight line under them. A straight line is referred to as a straight angle. And the vertex of this angle would be right here where they all converge. So this is like if I had two pens or pencils and they were on top of each other, and I started moving the top one until it came all the way around and stopped right here. They would form a straight line, theoretically. They would form a straight line. So this is referred to as a straight angle, and a straight angle has a measure of 180 degrees. So if I measured these angles correctly in my triangle and I added them together, I should come up with 180 degrees. So we'll see how close I was. I have 100 right here. I have 40, 50, 60, 70. I'm adding my tens together. Now I'm going to add my ones together. My 4 plus my 4 is 8, plus my 3 is 11. So when I add 100 plus 70 plus 11, I get 181. So I was a little bit off in my measuring, and that's okay. We're not perfect. But when you add your angles up in a triangle, you should always get 180 degrees. I was just a little bit off on one of my measurements. I'm pretty close. So that's the point of doing this activity today. It doesn't matter how large your triangle is or how small your triangle is. If you have a right triangle or if you have an obtuse triangle, if you have an equilateral triangle, it doesn't really matter. When you cut off all of the angles of your triangle and you arrange them together, they should always, always, always form a straight angle. This one I don't have tape for.